Hi everyone. Today we're going to review metric conversion, and as you can see I already created my anchor chart because I'd much rather spend the time talking to you about it rather than making it in front of you. I want to refer to you, I have this picture on my phone, I want to refer to you to this chart that we used in class. So this chart was that King Henry chart. So we use this in class a lot, and if you have your supplies you probably have it in your math notebooks, or you might have it in your math notebooks already, and you can use this chart to show how to move your numbers over to the right and to the left and what happens to them. So that's what I'm going to do today. Okay, so if you could see, I have my little pointer instead today. Instead, I have my unit here, and I labeled my unit. We're going to start here with a meter because that is the basis of linear measurement. Okay, that's the unit of linear measurement. So we're going to start here with our meter. Now notice my acronym. Remember, an acronym is just a way for us to remember the order of words or prefixes or anything that you need to remember. It's always good to create an acronym. So as silly as it sounds, King Henry died and usually drinking chocolate milk, it is something that we remember, and that's what helps us to know what comes next in our order of prefixes in this case. Okay, so let's quickly talk about linear measurement. So if our unit here is a meter, that means that we're going to go smaller here. So if we're going to look here, and that's abbreviated with a small m, anything smaller than that is if we were to take a meter stick, which I unfortunately don't have at home, but if we were to take a meter stick and we were to actually divide it or cut it into 10 pieces, then my number here is going to get larger because I'm going to have more pieces. So for that reason, I would take 10 times whatever a decimeter is and multiply it to get a meter. So for instance, if I had 1 meter, okay, and I multiplied it by 10, I'm going to end up to get my decimeter. So for instance, 2 meters times 10 is 20 decimeters. 4 meters times 10 is 40 decimeters, okay? The same thing happens here for centimeters. Centi, the prefix centi means 100, so this would be 100. So if I had 5 meters and I multiply by 100, that's going to give me 500 centimeters. That means if I had 5 meters and I cut that, or let's say I had 1 meter and I broke it apart into 100 equal pieces, each one of those equal pieces is going to be a centimeter. So if I had 5 of them, I'd multiply by 100 because that's 5 groups of 100. So 5 times 100 would be 500 centimeters. Milli, the prefix milli means 1,000. So in this case, I would multiply by 1,000. So let's say we had 3 meters. We wanted to break all of those 3 meters, each of those 3 meters into 1,000 pieces. That's 3 groups of 1,000. So 3 times 1,000 equals 3,000 millimeters. On the flip side, my arrows here are always going back to my meter. If I'm going this way, our prefixes mean that our amounts are getting larger, or the lengths are getting larger. So deca, similar to deci, also means 10, but deca means that if I were to have a meter stick and I actually took 10 meter sticks and put them in, back to back, that is going to be 1 decameter. Okay, so let's say I had, well, let's go basic. If I had 10 meters and I divided those 10 meters by 10, that's going to give me 1 decameter. All right, so if I had 40 meters, and I divided 40 by 10, 40 divided by 10 is 4. That means I have 4 decameters. Because 40 meters lined up, I can break them into groups of 10 and I'd have 4. Okay? Same concept goes to hectometer. Hecto, the prefix hecto means 100. So that means that if I lined up 100 meter sticks in a row, I'd have 1 hectometer. So think about that, 100 meters. If I were to divide it by 100, it would give me 1 hectometer. 100 divided by 100 equals 1 hectometer. If I were to have 600 meters in a row, and I divided my 600 meters divided by 100, it's going to give me 6 hectometers. All right, so although my linear amounts are larger, my number is smaller because I don't have as many pieces. Same thing on this way. So kilo means 1,000. So I would take my meters. So if I had 4,000 in meters, for instance, I divided by 1,000. It's going to give me 4 kilometers or kilometers. Now, the same thing goes the same concepts, the same conversions go if my unit is even different. So if my unit is liter in capacity, so this would be a measurement of capacity. So this is measurement of linear measurement. And this is a capacity, and this is mass or weight, okay? So if my capacity unit is a liter, then I have deciliter, centiliter, and milliliter, same conversions. And I have decaliter, hectoliter, and kiloliter, same conversions. Same thing goes for gram. If I have decagram, centigram, milligram, with my unit is gram, in decagram, hectogram, and kilogram, same conversions apply. All right? So I want you to think about this. If my numbers were to go this way, the number of my zeros is going to increase because the number of my pieces increase. So think about this. Like, for instance, if I had 1 meter and I want to know how many decimeters that is, well, I'm going to do 1 times 10 and I'm going to end up with 10. So 1 times 10 is 10. That means the number of zeros increase because I'm adding a 0. It really is interesting because every single time that I bump this way, I'm adding a 0. So I can go 1, 2, 3. Every single time I bump, I go to a 0. We're going to do some practice in a minute. In the same way, if I go this way, anyway on this way, the number of my zeros is going to decrease because I don't have as many whole pieces. Okay, so for instance, if I had 10 meters, and I want to know how many decameters that are, I'm going backwards and I'm going to lose a 0. So 10 meters divided by 10 is 1 decameter. So we're going to lose them. So this is kind of nice when we're pumping back and forth, and that's why we use this chart. So let's look at a couple examples for a moment, if you will. Okay, so let's take a look here. I know you can't really see all of this in my thing, but I created some practices. So let's look here. If we had, for instance, we wanted to go from meter, if we had 7 kilometers and we wanted how many meters that is. Let's take a look. Let me see. Can we see this in my chart? Yeah. Okay, so that means if I had 7 kilometers and I wanted to go to meter, well, I know that I needed to move this way on my chart, so I'm going this way. That means the number of zeros is going to increase. So if I'm at 7 kilometers and I want to go to meter, I'm gonna figure out how much I can do. Where's my pointer? 1, 2, 3. That means that I'm going to keep my base number of 7 and show my 3 zeros. Number of zeros increase. All right. So that means if I have 7 kilometers, it's actually the equivalent of 7,000 meters. All right, let's look at this one. 800 centimeters, how many meters is that? So 800 centimeters, so that's here. If I had 800 centimeters and I want to know how many meters it is, which way am I going? I'm going this way, right? And according to my chart, if I go this way, the number of my zeros is going to decrease. So if I have 800 centimeters and I need to go to meters, how much am I going to jump? I'm going to jump 1, 2. That means I'm going to decrease the amount of zeros or take them away. So if I were to take away my 1, 2 zeros, I'm simply going to end up with 8 meters. Now, does that make sense? 8 meters, each one is 100, and 8 times 100 is 800. Yes, it completely makes sense. So think about that. Look at this one. Millimeters. We want to know how many millimeters if we had 12 meters. So if I had 12 meters and I'm going 1, 2, 3 to get this way, what am I going to do? Number of zeros increase. So that means if I had 12, I'm going to add 1, 2, 3 zeros. That means I'm going to end up with 12,000 millimeters, which makes sense because each meter has 1,000 millimeters in it. So if I had 12, I'm going to have 12,000 millimeters. All right. Let's look at something with liters. So what if I had, I'm going to fold this down here. What if I had if I wanted to know how many milliliters in 2 liters? So remember, my liter is my unit, okay? My liter is my unit. So if I had, if I wanted to go from liter to milliliter, and I know I had 2 liters, let's check my thing here. If I'm going to go this way, the number of my zeros is going to increase. So let's see, if I had 2 and I need to get to here, I'm going to go 1, 2, 3. So that would be 2 plus 1, 2, 3 zeros would mean 2,000 milliliters, which makes sense because for every 1 liter, there are 1,000 milliliters. So in 2, there's going to be 2,000, okay? How about this one? Kilogram, so, we're going to talk weight now, so mass. So kilogram and gram. Now gram is our unit. So gram here is 4,000. So if I had 4,000 of these and I needed to go this way, let's check. Our number of zeros is going to decrease. So if I had 4,000 grams here and I wanted to go to kilogram, I'm going to go 1, 2, 3. That's 3 zeros that are decreasing. So 1, 2, 3. I'm going to take 1, 2, 3 zeros out. It's going to give me 4 kilograms. Does that make sense? If I had 1,000 grams, that is equal to 1 kilogram. So that makes sense. So on this chart, so there's my examples there. So I'm going to give you a little picture of that right there. Okay, I'm not going to post that picture. I'm just going to show these examples to you so you can come back to them if you need to. But really pay attention to this. Number of zeros decrease, number of zeros increase. Our unit, our meter, our liter, and our gram. Okay? Great? Awesome. This is not easy, so it's a good job for watching this video. Let us know and reach out if you have any questions.